In today's lecture, we are going to continue with the convergence of the real sequences. So yesterday we were doing convergence of real sequences, and we understood what is the meaning of convergence. That is, if the limit of the sequence is unique and it exists, then we say that the sequence is convergent. In other words, we also understood the fact that if I say that my sequence is convergent, then xn, and let's say it converges to x. Let's say xn converges to x, then xn minus x modulus can be made less than epsilon for all n greater than equals to n naught. Okay, for all n greater than equals to n naught, I can write this way. Okay, and certainly a few more things we also discussed yesterday. I would advise you that before today's lecture, if you've not seen today's lecture, kindly go and see yesterday's lecture. Sorry, if you have not seen yesterday's lecture, before seeing this today's lecture, kindly go through that previous lecture. Okay. Now, today let us start with a few more other things, and let us begin. Okay. So yesterday we actually discussed in the last that a sequence which is convergent is bounded and not converse true. So this was the last thing that we did. Now today we are going to do something called as algebra of convergent sequences, and this is something that I'm not going to derive. The derivations are given, the proofs are given in the book, but still a few of them I will attempt just to give you an insight. Okay, so algebra of convergent sequences. So let there be two sequences. Let xn be convergent towards x and yn be convergent towards y. Then, and let us say alpha belongs to R. Let's say alpha belongs to R. Then xn plus yn converge towards x plus y. In fact, if you take a negative also, then it will also do. So xn plus minus yn would converge to x plus minus y. Alpha times xn, this alpha times xn would converge towards alpha times x. Xn times yn would converge towards xy, and xn by yn would converge towards x by y, provided y is non-zero. So this is what is called as the algebra of convergent sequences. This is what is known as algebra of convergent sequences. Now you see, if you want to prove it, I will prove a few of them, like a couple of them, the first two of them. The last two of them I'm giving you as a homework. Try to do these things as a homework. The proofs are given in the book, but just to make you a little bit oriented towards the proof or proof writing, I would do the easier ones. So basically I'm doing these are easier ones. Okay. So I told you, whenever I say that my sequence is convergent, then the limit xn is equals to x, or I mean that xn minus x can be made less than as small as a possible number for all n greater than equal to some number, let's say n naught. Now when I say that xn converges to x, yn converges to y, and if I say that xn plus yn converges to x plus y, what do I need to do? I need to estimate xn plus yn minus x plus y. If I estimate this, and this estimation comes out to be less than epsilon for all n greater than equals to some number, then I would say that limit xn plus yn is equals to x plus y according to the definition of the convergence of the sequences. So I hope it is clear. Now you see, if I'm saying that xn converges to x, that implies what? This implies xn minus x ka mod can be made less than, let us say, epsilon by 2 for all n greater than equals to n1. Okay, if I'm saying that yn converges towards y, then what do I mean? I mean that yn minus y ka mod can be made less than epsilon by 2 for all n greater than equals to n2. Okay, now consider this, that what we need to estimate, we need to estimate xn minus x plus yn minus y. So what I have done, I have written this particular thing as xn minus x plus yn minus y, which can be made less than xn minus x ka mod plus mod of yn minus y. Okay, now if I select the maximum of this n1 and n2, let us say that maximum is n0. If I select maximum of n1 and n2, for this n0, I can say that this would be less than epsilon by 2 and this will also be less than epsilon by 2. It implies what? It implies modulus of xn plus yn minus x plus y can be made less than epsilon for all n greater than equals to n0, where n0 is maximum of n1 comma n2. And what does it imply? It implies that limit xn plus yn is simply equals to x plus y. I hope you are getting this. If there is a problem with this, please let me know. I don't know if somebody has joined. If somebody has joined, kindly let me know through the comment box. If you are not following, please let me know. I mean, this is an easy proof. And why do I do proof? I do proof because I want you people to understand how to write proofs. Basically, this is what is required. If you are able to think rigorously, then lately you are going to do each and every question that I'm going to give you. Okay. So now next thing that comes up is this one. So the second thing in algebra of convergence sequences is that if xn converges to x, then alpha times xn must converge towards alpha times x. How to do this? This is again an easy thing. If I'm saying that xn converges to x, it implies xn minus x mod can be made less than epsilon for all n greater than equals to some natural number, let us say n0. And if this is the case, okay, and similarly what I can say, I can also say that xn minus x can be made less than epsilon by mod of alpha for all n greater than equal to some n1 belongs to natural. Okay, now let us estimate. What we need to estimate? We need to estimate the distance between alpha xn and alpha x. My claim is that alpha xn converges towards alpha x. So alpha x is the limit of alpha xn. So what do I need to see? I need to see the distance between alpha xn and alpha x. So let us estimate alpha xn minus alpha x, which is equivalent to writing modulus of xn minus x. And we know that for all n greater than equals to n1, xn minus x can be made less than epsilon upon mod of alpha. This I can do for all n greater than equal to n1. What does it imply? It implies that alpha xn minus alpha x can be made less than epsilon for all n greater than equals to n1 belongs to natural. What does it mean? It means that limit alpha xn is equals to alpha x. So all these things you can do on your own also. I'm leaving all these things as an exercise for you. If you're not able to follow, please let me know. I think this is something that you can do on your own also. So the remaining two things I'm leaving up to you. Like if you have to prove that xn converges to x and yn converges to y, then xn into yn converges towards x into y. Okay, so this is what this is something that I'm leaving it up to you. Now you see, if I want to write a few more things about this algebra of convergence sequence, then what those things could be. So let us define a set C of convergent sequences. Let us define a set C of convergent sequences of real numbers. Of real numbers. Okay. Then this particular set C of convergent sequences form a vector space. This is something, again I am leaving it to you. This is an easy exercise for you. See, all the convergent sequences form a vector space. Why? Because you know that the constant sequence 0 0 0 0 will give you this identity. If xn is convergent, then minus xn is also convergent. So you'll get, for corresponding to xn, you can get a minus xn, and all the other properties you can verify yourself, since I know that alpha xn is equals converges to alpha x. So all these things, if you keep in mind, then you can prove easily that the set C of convergent sequences of real numbers form a vector space. Under what? Under operations. Let us define those operations so that you don't get confused. Under two operations, and these two operations are one, addition. So xn plus yn is equals to xn plus yn, that is adding each of these things, each of these, and alpha times xn is equals to alpha xn. I think you know the properties of vector space. You can prove it. I am giving you the hint that the zero sequence is also a convergent sequence. Please understand. If xn is convergent, then minus xn is also convergent. So existence of inverse is also there. If you add two of the sequences xn plus yn, this is a real sequence, then this is also a real sequence. Closure holds. Since addition itself is associative, so whether you add yn plus xn and all the other properties which relates to the scalar multiplication, you can prove on your own self. This is something that I expect you should know at PSC level. If you don't know, please let me know in the comment section. I will do it in a different lecture altogether. But always remember, the set C of convergent sequences of real numbers forms a vector space. Okay, now let us just move to a few questions, and if there is someone who's listening to this lecture, please let me know uh, the answers for the same. So now I'm giving you a few questions. Let us understand who knows it and who doesn't know it. Okay, so let us do a few questions. So let's say if both xn and yn are unbounded. Both xn and yn are unbounded sequences in R, then xn yn cannot be convergent. True or false? Then xn yn cannot be convergent. True or false? I'm giving you 2 minutes to think about it, and if you're not able to think, then I'll solve the question for you. So it says that if xn and yn are unbounded sequences in R, then xn into yn cannot be convergent. That is, then if xn and yn are both unbounded, then multiplication, that is xn yn, must be a divergent sequence. This is what it says. Is that always true? So answer to this question is no, false. Why it is false? I'll give you an example. I will give you an example. So let us think that let us define xn to be equals to let us say 1 0 2 0 3 0 4 0 5 0 so on and so forth. And let us also define sequence yn in this fashion: 0 1 0 2 0 3 0 4 0 5. And if I'm multiplying these two, what it means, it means I'm doing x1 into y1, x2 into y2, x3 into y3. So I'm getting what? I'm getting 0 0 0 0 0 dash 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 0. Isn't it a convergence sequence? This is a convergence sequence. Why? Because it is a constant sequence. If a sequence is a constant one, then it is always convergent. Please remember this. Now let us move a little bit further. Just let me know this particular thing. Okay, so if xn and yn are sequences in R, if xn and yn are sequences in R such that xn is convergent and yn is not convergent. Yn is not convergent in R, then xn plus yn cannot be convergent. True or false? Just let me know. Okay, just let me know. I'm giving you 2 minutes. Try to solve this. And if you're not able to solve this, then I'll do it for you. Okay, so if this is the question, then let us solve it for you. Let me solve it for you. Okay, so what is given? If xn and yn are sequences R and xn is convergent and yn is not, so yn is not given to be convergent, then xn plus yn cannot be convergent. Is it true or false? This is not true. Let me show you why. So answer, sorry. So what is given? Sorry, this is true. Indeed, this is true. Okay, this is indeed true. Why this is true? Because see, yn is given to be non-convergent, right? So if a non-convergent sequence is added to a convergent sequence, then it cannot be convergent. Let us see how. So let me just write that if let me just write the contrary. So I'll write, let us assume contrary. Let us assume the contrary. And what is this a contrary? The contrary is, let us assume that xn plus yn, let it be convergent. let it be convergent. What would be yn? Yn would be nothing, but it is equals to xn plus yn minus of xn. Now, from algebra of convergent sequences, we know that if this is convergent, and since xn is convergent, so let's say xn converges to x, then minus of xn is also convergent, it converges to minus of x, and this is also convergent. What is by algebra of two convergent sequences, we know that yn must be convergent, but that is not the case. So by contradiction, we arrive at a fact that the assertion is wrong. That is, we cannot have xn plus yn to be convergent. Rather, it would be divergent. So it cannot be convergent. Yes. So always read the statement. So initially I was reading the statement in mind that xn plus yn is convergent. No, it cannot be, because if you add a divergent sequence to a convergent sequence, then it cannot no longer remain a the sum cannot remain a convergent sequence. This is what I have proven also. I hope it is clear till now. Let me go to a little bit further and do a few more questions for you, and then you maybe let me do a few more questions, or should I first fix something and then should I move ahead? So let us do a few more things, and then probably you'll be able to understand what I want to teach. So the question is, if a sequence xn in R, if a sequence xn in R which converges to 0, if a sequence xn in R which converges to 0, then xn raised to power n must converge to 0. True or false? Must converge to 0. What do you think? Whether it is a true statement or is it a false statement? Just let me know. What do you think about this statement? So see, so if xn is a sequence which converges to 0, okay, so if xn is a sequence which converges to 0, what does it imply? I'll write xn converges to 0. And what does it imply? It implies that xn minus 0 mod can be made less than epsilon for all n greater than equal to some natural number. Let's say n naught belongs to n. Now, if it can be made less than epsilon, and epsilon is any arbitrary positive real number, why not select epsilon to be, let's say, equals to half? So what does it imply? Xn minus 0 can be made less than half for all n greater than equal to, let's say, some capital N belongs to natural number. Now, I know that xn ka mod ki power n, if I'm writing, it implies I'm writing power here, and since it is greater than, so it is modulus, so it should be greater than 0. Now, if I apply Sandwich theorem, if you are not aware of Sandwich theorem, I'll teach you someday. But I think from standard 12th, if you're slightly aware of this theorem, then it would be very good. So Sandwich theorem says that if there are three functions, or let's say three sequences, I'll teach you today itself. Let's say I'm talking in terms of function. If you have these three functions, and if the limit hx is simply L and limit fx is simply L, then the limit gx is also L. So this is how it is. So by Sandwich theorem, I know that limit 1 upon 2 raised to power n is equals to 0. What does it imply? It implies that limit xn raised to power n, or whether I write this way or I write this way, this is one and the same thing. Okay, so it implies what? It implies, if I'm writing this, what does it imply? It implies xn raised to power n minus 0 mod. So writing this is equivalent to writing this. If I'm writing this way, I know from both of the sides that limit xn must be equal to what? 0 only. Whether I write this way or whether I write this way, it is one and the same thing. So what does it imply? If n tends to infinity, then this is going to 0. N tends to infinity, here it is bounded by 0, here it is bounded by 0. It implies limit xn raised to power n must also be 0. So the sequence xn raised to power n is also a convergence sequence, and rather it converges towards 0. I hope it is clear. I hope it is clear. Now, let us further move to another question, and let us see if you are able to do it. So the question says, there exist, you have to state me true and false, there exist a non-convergent sequence xn a non-convergent, please remember non-convergent I'm saying, a non-convergent sequence xn in R such that xn plus 1 upon n xn is convergent. True or false? What do you think an answer would be? So just let me wait for a few people to join and then we'll again start. So just think about it and then we'll. Okay. So let me now solve it for you. Since nobody is answering the question, so let me solve it for you. Okay. So what it would be? So what am I saying? Okay. So what am I saying? I'm saying, does there exist any non-convergent sequence xn in R such that xn plus 1 upon n xn plus 1 upon n xn is convergent? So the answer to this would be, I guess, false. Why false? What do you think? Why false? So what I will do, in order to prove it, I will take the statement to be true. So let there exist a non-convergent, NC means non-convergent, sequence xn in R such that let's say this is your yn is equals to xn plus 1 upon n xn, such that yn is convergent. So the statement says that does there exist a sequence xn in R such that xn plus 1 upon xn is convergent? What do you think? Answer should be true or false? So answer would be false. And let me explain you why. So what I'll do, I'll assume that some sequence xn plus 1 upon xn is, let's say, yn. And I will assume that let there exist a non-convergent sequence in R such that this yn is convergent. So yn is convergent means what? What do I mean? Yn is convergent. Yn is convergent implies xn plus 1 upon n xn is convergent, isn't it? So if I'm saying that yn is convergent, it implies yn was equivalent to what? Yn was equivalent to xn plus 1 upon n xn. So I'm assuming that there exists a non-convergent sequence xn in R such that yn is convergent. What is yn? Yn is xn plus 1 upon n xn. Now you see, if I'm saying that yn is convergent, it implies yn must converge to some limit, let us say y. Okay. And if yn is convergent, then this should be convergent because yn is after all equal to this. So I should write that xn, if I take this common out, 1 plus n, and here it is y. So it implies xn should be equals to what? Yn upon 1 plus 1 upon n. And if yn is convergent, then this converges to 1 upon, because n tends to infinity, 1 upon n tends to 0. That implies this converges to y. And what does it imply? It implies that xn converges to y, which cannot be the case, because we are saying that there exists a non-convergent sequence xn in R. No. So if xn plus 1 upon xn is convergent, then xn has to be convergent. It cannot be non-convergent sequence. So what do you think answer should be? Answer should be false. I hope everybody is getting the point. If anybody is not getting the point, please let me know in the comment section. Has anybody joined? If anybody has joined, please let me know in the comment section. I am right now discussing convergence of sequences, and we have done some algebra of convergence sequences, and now I'm discussing some questions. So let us think about it. Has anybody has got any problem? Please let me know. If there's a problem, please let me know, and then I'll be able to help you out. Okay. So now I'm giving you another question, and let us think. Let us see that who solves it. So question is simple. Question says, there exist, you have to give me true and false. There exist a non-convergent sequence xn in R such that xn square plus 1 upon xn is convergent. True or false? You have to give me about this sequence, whether this is convergent or not. Earlier what I had told the question was, I was giving you, let there exist a non-convergent sequence xn in R such that xn plus 1 upon n xn is convergent. True or false? Answer is false. Why? Because let us assume that there exists a non-convergent sequence xn in R such that yn, which is given by xn plus xn upon n, is convergent. So if yn is convergent, that implies yn converges to y. That implies xn plus 1 upon n xn should also converge towards y. It implies xn is equal to 1 plus 1 by n equals to yn. So xn can be written as yn upon 1 plus 1 plus 1 upon n. As n tends to infinity, this will go to 0. So it implies that xn is convergent, which indeed is not the case. So clearly I can say that there is a violation, or my assertion is false. And if my assertion is false, then obviously if my assertion is false, so by proof by contradiction, I can write that there does not exist any non-convergent sequence in xn in R such that this particular thing is convergent. I hope so. I'm right now teaching you some questions. Through some questions I'm going to teach you. Please try to do this question. I'm giving you 2 minutes to solve it, and then I'll come. Okay. So let me solve it for you. Yes, indeed, the answer should be true. See, here you can give an example also. Okay, so does there exist a non-convergent sequence xn in R such that xn ka square plus 1 upon xn is convergent? True, yes. Indeed, you can give an example here. Take example, xn is equals to minus 1 raised to power n. Okay, if you take this example, then what would be xn ka square? Xn ka square would be simply 1, 1, 1, 1, 1. So limit xn ka square would be what? It should be 1. And if I write this as 1 plus 1 upon n into minus 1 raised to power n. This particular sequence can be written in this manner. And if I take the limit would indeed come out to be equals to what? Limit indeed would come out to be equals to 1 only. So clearly this is convergent. Yes, there exists a non-convergent sequence xn in R. Yes. If it had been given positive, then I cannot say, then I don't have right now any counter example or any example to to prove it. But the question was given for xn in R. Xn in R matlab you are given that just give me any real sequence. So yes, this indeed is a real sequence. It is indeed is a non-convergent sequence. And if this is a non-convergent sequence, then xn ka square plus 1 upon n xn is indeed convergent. So I hope till now everything is clear to you. Now let us move to little bit of theory and then we'll do questions. So let us move to a little bit of theory and then we'll do questions. Okay. Okay. Now, one another definition to convergent sequences is saying that sequence is Cauchy. So what do you mean by Cauchy sequence? Let us write. Cauchy sequences. So a sequence is said to be Cauchy a sequence is said to be Cauchy if for each epsilon, that is, you give me any epsilon, for each epsilon greater than 0, there exists some natural number. There exists some natural number, let us say capital N, such that for all m and n greater than equals to n, we have xm minus of xn or xn minus of xm less than epsilon. That is, this is true for all n greater than equals to m greater than some capital N belongs to natural. What does it mean? It means that if your sequence xn is Cauchy, then after some natural number, distance between two elements of the sequence can be made as small as possible. So this is also highlighting towards convergence only now. If I'm saying a sequence is convergent, let's say I'm saying sequence is convergent, let's say xn converges to x. What does it imply? It implies that distance between xn and x can be made as small as possible. Okay, yes, indeed it is the case. Why? Because see, if I'm saying sequence is convergent, implies what? Implies that all the elements of sequence are getting as close as possible to x. And what do I mean by as close as possible to x? In mathematics, you have to write it in the formal sense, right? So if I'm saying write it in formal sense, so what you will say? You will say that distance between xn and x can be made as small as possible. Let us say that distance be epsilon, and this distance be not this way. You give me any distance. You give me any distance means you give me any arbitrary positive real number, and I will produce some natural number corresponding to this epsilon such that beyond this natural number or after this natural number n naught, xn and x, the distance between xn and x can be made as small as possible or as desired. So therefore it is written, given epsilon greater than 0, xn minus x mod is less than epsilon for all n greater than equals to n naught. It does, what does it imply? It implies xn converges to x. So this is one of the ways of saying it. So for example, here is your x1, here is your x2, here is your x3, here is your x4, here is your x5. But after some natural number, what will happen? Let us say this is x. So what will happen? All the terms of the sequences that you're getting, all the terms of the sequences that you're getting will be contained in this x minus epsilon to x plus epsilon. all the terms of the sequence will be contained in this only. So your all the terms of the sequence xn will be contained in x minus epsilon to x plus epsilon when for all n greater than equal to some n naught. This is sometimes referred to as the tail of the sequence. This is sometimes referred to as tail of the sequence. Always remember when we are doing real number space, that is we are dealing with a connected metric space, that is R. There we can write one generalization, that is a real sequence xn is Cauchy if and only if it is convergent. So what does it imply? It implies if I say that my sequence is convergent, then my sequence is Cauchy, or if I say that my sequence is Cauchy, then sequence is convergent. So this is a very powerful statement, that if you want to prove anything convergent, just prove that it is Cauchy. If you want to prove any sequence convergent, just prove that it is Cauchy. Or if you have proven something as Cauchy, then you can say that that particular sequence is convergent. I hope it is clear. In fact, if a sequence is Cauchy, then it is convergent. So it implies also that any Cauchy sequence is bounded as well. Because yesterday I taught you that every convergent sequence is bounded. So if any Cauchy sequence is also bounded. Any Cauchy sequences bounded. Okay. So now let me just ask you if everybody is following this particular lecture in comment box or not. Please don't have impatience. I'm just saying initial days I'm going to give you some initial definitions, okay? Because if I'm not going to give you, one day when you're going to revise all these things, you will not be able to make any sense. So that is why I'm saying please do attend all these lectures also, because if you're not attending them, then you'll not be able to gain anything. Okay, so now let us move further. So what do I mean? So now try to write, if so, question I'm giving to you is, let xn be a Cauchy sequence. Let xn be a Cauchy sequence. Let xn be a Cauchy sequence such that, now just give me answer to this problem. Let xn be a Cauchy sequence, let xn be a sequence such that modulus of xn is less than equal to 1 plus n divided by 1 plus n plus 2n square for all n belongs to natural. Then xn is Cauchy. True or false? Xn is Cauchy. True or false? Is there anybody who is watching this particular lecture? If yes, please let me know you are getting the question or not. Question says that let xn be a sequence such that modulus of xn is less than equals to 1 plus n divided by 1 plus n plus 2n square for all n belongs to natural. Then xn is Cauchy. True or false? Just let me know. If there is someone on live right now watching, please let me know. If you're getting the question, please let me know yes or no. If you're not getting the question, I will repeat the question. Don't worry. I'm giving 2 minutes to solve this particular thing, and then tell me yes or no. If this is true, then tell me true. If you think this is false, then let me know if this is false. Okay, so I don't think anybody has got any answer to this. Let me solve it for you. See, let xn ka mod be a sequence such that xn ka mod is less than equals to 1 plus n plus 1 plus n. So what should I do? I will write it in this fashion. Xn ka mod is less than equal to, let me write it as 1 plus n plus 2n square, okay, minus 2n square divided by 1 plus n plus 2n square. Okay, let me write it in, write this in this fashion. Okay, it implies what? It implies xn ka mod is less than equal to, xn ka mod is less than equal to 1 minus of 2n square upon 1 plus 2n square. I don't think this is going to yield you any answer, right? Okay, so this approach fails. So let me not go through this approach. Let me not go through this approach. Let me try some other approach. So what do you think the right approach would be? What do you think the right answer would be? Do you think that xn should be convergent? Please let me know. Is there anybody who is on the chat? Please let me know. Do you know the answer to this? So this approach is not going to work. Then what should I do? What approach should I take? Okay, so let me help myself. I'm going to do this for you. Okay, so nobody has got any answer. So let me solve it for you. So this approach is not working. Okay, so this approach is not working. So what I'll do, let me try to estimate something. Let us estimate xn ka mod minus xm ka mod for all n greater than m greater than equal to m greater than some natural number belongs to m, sorry, greater than m greater than m greater than equal to some natural number belongs to n. So, and what is xn ka mod given to be equivalent to? Xn ka mod is written less than equal to 1 plus n divided by 1 plus n plus 2n square. So it is equivalent to having written this. So I can simplify this, isn't it? How can I simplify this? Because if I cannot simplify this, then there would be a problem with this. There would be a problem with this. Therefore, I'm saying try to simplify it. Try to simplify it. Otherwise, there will be a problem. You'll not be able to do this question. So is there nobody today? I wanted to solve it in front of everyone, but there's no one today. So let us estimate xn minus xm mod at once. So let us estimate xn minus xm mod.